Hey there, everyone. Today, I want to take you through the topic of natural language processing. We're going to be focusing on Amazon reviews. I'm just going to give you a general overview of several topics in the NLP world. Of course, I'm going to keep it very generic and try to make it applicable to your specific use case. You probably won't be analyzing Amazon reviews, but there's so many applications for NLP processing. I'm hoping that the takeaway is you can understand what I'm talking about, digest it, and then apply it to your own specific situation and solve your specific problems that you're dealing with. Okay, so NLP is a way to gain insight into language, understand syntax, any kind of business, customer, naming conventions, research of language, essentially. Understanding customer sentiment is important, feature extraction, be able to do competitive and comparative analyses, personalized recommendations for targeted marketing. We can generate automated responses for customer inquiries. We can do detection of fake reviews and review verification, content analysis, behavioral insights, trend analysis, is so many things. So let's jump into it. We're going to import some commonly used libraries in the world of NLP and load a couple of plotting libraries so we can visualize some of the data and get a general understanding, a general sense of what is in the data, what the data contains, and so on and so forth. And we'll generate some charts to prove that. A picture is worth 1,000 words, right? So you can take 1,000 words to describe something or show somebody a picture of something, basically a chart or a graph, and communicate the same message. The image will communicate the message much more quickly and efficiently. Okay, let me load the data here. So everything is coming from my desktop into a data frame, aptly named DF, abbreviated DF. So we have some notifications here, no warnings, no errors or anything, just some details about the natural language toolkit libraries that we're working with. So this is what the data frame looks like. We have ID, some dates, name, brand, what else? Category, primary category, and then subcategories, things like this. So pretty intuitive, pretty relevant, generic to your Amazon reviews, right? So let's go down a little bit more. What's the first thing we're going to look at? Missing values. So if we have a lot of missing values, especially if you have more than about 50% in one feature column, you probably won't be able to use that as a tool to train your model because there's too many nulls or too many missing values for the model to learn on and to understand and make meaningful predictions. It's just not going to work, right? So we might have to abandon some of these columns, but let's see. It says date added. We have a bunch of missing, almost 80%. Review ID. So yeah, we have some fields that we just won't be very useful. But for most of these, we have no missing values, so it's pretty comprehensive. Again, here we have some missing IDs and date added. But you know what? We can easily do without the review ID. At this point, that's not concerned, and the review added is totally fine. As long as the rest of these are zeros, which means non-null, then we're totally fine. We can move forward, okay? So that's one thing you should check in your data to see if anything's missing. You can do an EDA experiment where you do exploratory data analysis and you just plot the missing values on a chart and see if anything's missing, or you can count it. We did the counting method, but plotting is just as good, I think. Some of the data does come in a little bit funky, so I'm going to clean it up. I'm doing some string conversions to make sure that this is actually a string object and not something else. String replace, I had a couple weird characters I saw in the data like this. I'm replacing that with nothing. So string.replace replaces whatever the character is, \d, I think that's a return character, with nothing. I'm just clearing those out. Again, here's some funky characters, probably non-printable characters. I want to clean up the data set. Okay, that's all we're doing here. So we get this. I am parsing out some year, month, day, weekday dates for review date, and we can take a look at that. The data comes in a little bit funky here. They have this convention, 2018 10 25. So this is October 2015. Sorry, October 25, 2018, and then you have this T. I think this is a time zone format. So that is not anything that I'm concerned about working with. So I'm going to remove those time zone formats. That's why I set the extra dates. And we may or may not use this date, but at least we have clean dates over here. We have year, month, day, weekday. So this is, let's see, 0, 1, 2, 3, 4. This would be a, I think it starts Sunday, Monday, Tuesday, Wednesday. So this would be a Wednesday. Or they start with Monday, Tuesday, Wednesday, Thursday. I forgot offhand, doesn't matter. All we have is a nice clean date at the end right here, review date. So that could be very useful if we're looking at any kind of time series analysis. Okay, so let's keep going. Again, looking at, is anything missing? I just want to be sure that when we're working with these models, we don't have nulls that's going to cause the model to fail, or nan. A null is nothing, a nan is not a number. A 0 is okay. We can feed in zeros. We can convert any nans or nulls into zeros. That's totally fine. But if we have a whole bunch of missing values in that conversion, again, the ML model is probably not going to perform too well given that specific feature. So we just want to understand what's missing and accounted for, and what is what's missing and what is accounted for. Okay, so those two things. I think we're in good shape here. We have review ID. Again, I'm not concerned about the IDs in this case. So let me plot primary categories. That's one of the fields that we see over here. If we go primary category, let's see what this looks like. And we'll hit Control Enter to refresh it. So primary category, electronics, electronics and hardware, office supplies, and electronics and media, right? So we're talking about Amazon. This totally makes sense. We have a plot of the categories, and we can see it's all IT based, right? So that's excellent. Now I'm going to show you word cloud. You've probably seen this. These are becoming pretty popular. If you haven't seen it, I'd be kind of surprised. These are showing up everywhere now, even in the news and things that you wouldn't necessarily think of using word clouds. The larger the word and the bolder the shape, or basically the larger the word, the more frequent the occurrence, right? So you can see love and use is coming up over and over again. People love what they buy at Amazon, right? It's a good product, good price, fast shipping. So this comes up a lot. You see smaller words like light, best, app, price. It's some of the smaller ones I see little, set. So these words are just used less frequently. The bigger the word, the more frequency they show up, and the smaller the word, the opposite. Okay, so kind of the same thing here. The orientation of the word, if it's vertical or horizontal, doesn't matter. It's just like the boldness or how large the word is. Okay, so in this case, great is the most frequent word, and it looks like tablet is second. And this is just a plot. We can certainly count these words, and we will do that. We will do that very shortly. So this is just one interesting view that I want to demo here today. So let's look at a pie chart to see what percent of the total categories, or the breakdown of the primary categories. Okay, so electronics, clearly 2/3. Let's see, what is this? Electronics, hardware, also electronics. So 66 plus 29, we have like about 95% there, 94%. Office supplies and electronics and media. It seems like this electronics media could easily be absorbed into electronics or electronics hardware, although maybe, who knows, maybe that's a DVD or something like that. I don't think people really buy DVDs anymore at this point, but apparently that was some kind of media-based electronic. Okay, so we got that. Now looking at title and reviews, kind of similar thing, pie chart here. Great product, great tablet, love it, so on and so forth. So the mood here is obviously positive. I'll do a sentiment analysis right at the end of the demo here, but definitely positive. People love it, great product and great tablet. That accounts for 50% of the counts of the user reviews. Okay, so moving on here, we can get a sense of which this is. Let's see, counting review list. Okay, yeah, here's the number of counts. So this is how we're getting it. Great tablet, great product, love it. So here's the actual counts for the chart that we see above, right? So easily, great product, great tablet, great product, love it, and then great is third. Okay, and here's the counts. So we're just listing those out. So we have the data to back up the chart. So that is great. Here is a bar chart of the frequency of words that show up in these Amazon reviews. So you can see easily the comes up with the most, and, to, I, it, for, a, is, my, and this. This is like the top, I guess 10, 9 or 10, maybe 11 there. So it ends at this. But if you think about it, none of these words are really meaningful. They don't add a whole lot of context to the review. What we really want to see is tablet, maybe the color, something that is going to describe what was being bought. They, and, to, I, it for doesn't tell me anything about the product itself, right? It is simply just part of the review, but doesn't add any meaningful significance to the syntax, right? We're looking at this this feature review text. So let's take out these words. It's called stop word removal. And if we remove all the stop words, I've got all the logic here, but you can Google this. There's a few different ways to do this. Once we review all the stop words and replot this, we're going to have a very interesting result here. We're going to have only the meaningful, significant words that actually add value to the actual review, and we can understand how satisfied or dissatisfied a customer was, and probably what the product was too. So you see, great, love, tablet, use, easy, bought, Amazon One, Kindle, Echo, good. So all the words like the, is, and, that doesn't add anything to the analysis, right? It's a word that's used very common, but you need to know, you need to really understand what's happening and know how to extract value from it. If you're just getting the, is, and, there's no value there, right? You have to have a real word in English that has a purpose in it and a real meaning. Okay, so I think we accomplished that. Here we can see the weights of all of the terms. You see great, tablet, love, use, easy, and then the percentage of time that shows up. So that's interesting. Instead of counting the number of times, we're counting the weight of the word relative to all of the other words that show up. So these are the top numbers in descending order, top weights in descending order. Okay, now we're going to do count vectorizer. Again, remove all the stop words using English pre-trained language model here. And we are going to do a, what is this? Which kind of test? Multinomial fit. Multinomial fit for accuracy of calculations. Okay, to figure out the accuracy of this model to make predictions. So this is pretty standard data science. We break the data set into, we split it into Y train, Y test, X train, X test. The testing size is 30%, so the training size is 70%. This can be, testing can be 30, 25, 20%. It's really up to you. It's somewhat arbitrary. You do have to have a holdout set. You can't have zero testing, right? Otherwise, the model is going to see everything in the entire data set and memorize it, and it's not going to be able to make predictions on the unseen portion of the data. So you have to have some kind of holdout set or test set, okay? So when you run this model, we can see it's about 70% accurate. That's okay. That's decent. Higher is better. If you can get up to 90, that's preferred. But 70% is not horrible. It does leave a little room for improvement, because 30% of the time this model is probably going to make inaccurate predictions. We really want to try to test different models and get this number up higher. So it's not just 70%, but more like 85 or 90%. So it's two more. I'm doing SVC and KNN predictions. So this is sport vector classifier and nearest neighbor classifier. Now we have 71%, 68%, still not great. But you know what, in that case, that leaves opportunities for improvement. We can test a whole bunch of different classification models. I'm going to produce a video about that pretty soon. There's about 40 in the ML world, 40 classifiers and 40 regressors. And you can loop through all of those very quick and very easy, pick the best model and then apply that. This is just an NLP video, so we're not focusing on machine learning. I admit that this can be improved, and in a real world setting, I would improve this, but at this point, I think we tested a few ideas. Didn't really work out as well as we had hoped for, but that's fine. We'll use another technique called lazy learn to get that. We'll have another video coming out about that. So now we're looking at topics, and we have the top 10 topics. We start with 0, Python 0 base, so you always start with 0. This is really the first, but you don't start with 1. It's always 0, 1, 2. 2 is actually 3. It's the third iteration, but when the developers created this, they just thought it'd be fun to start with 0-based indexing, I guess. So here's the top words for this topic: use, purchase, size, like. This is another group of topics. Nice. Oh, niece. N-I-E-C-E, niece. Yeah, niece, nephew. Okay, I didn't know if they misspelled nice. I think that is actually niece, nephew, mother. So these words go together, right? That's why these are grouped together. So syntactically, this is the same type of description of a person. I mean, generally, like this is family titles, right? Christmas, daughter, that goes in that group. Mom, son, simple, light, easy to use, so on and so forth. So we have different groups of words, right? And there's all kinds of clustering exercises. I have another video on clustering text. So there's a bunch of ways we can go. Again, this video, I'm just introducing some of the more common topics and just demoing how these things work. So we won't get into clustering text, but that is another avenue that you can go down. So this is Sentiment Analyzer, and we can use this to understand how positive, neutral, or negative these reviews were for people, right? So it's pretty easy to set up and use. Again, I'm going to share all this code with you. When I post a video, you'll have all this source code. You can copy and paste it and run this in your own Jupyter Notebook environment. I went through a little bit fast today, but I can't go through every nuance and every detail of everything. The video will just drag on and on. So trying to just introduce ideas and concepts, showcase how this stuff works, and try to give you some ideas how you could, so you can adapt this for your own specific use case. So let's do one more quick plot on this data so we can get a sense of how positive, neutral, and negative these are. And overwhelmingly, all these reviews are positive. There's a few negatives that stuck in there, a couple neutral, but most people are pretty happy with what they got, right? So let me refresh this cell and see what this looks like. TF-ID vectorizer. So text frequency is TF. IDF is inverse document frequency. This takes all the text and converts it into numerics, because computers understand numbers very well. They don't understand letters and words and combinations of words very well. But if we vectorize this, the computer can use this to make predictions, to train a model and make predictions into what's going to happen next. So that's exactly what we're doing here. This is a random forest classifier. Again, we looked at a couple classifiers up above. This is another type of classification model. This is running right now. Should be done momentarily. And as it works, I think we're about to wrap up. Just to keep in mind, evaluate the performance of your ML models. If you're making these predictions, you want it to be at least 90% or higher. If those models don't work, that's fine. Just pick another model. Or you have to fine-tune the hyperparameters, or get a larger data set. Maybe the data you're working with is too small and the machine can't learn enough comprehensively. That can be another issue. And there's a few other things you can try. If your model's underperforming, you can Google it and get a bunch of ideas. There's quite a few fine-tuning elements that you can mess around with. And then just one more thing down here. I created a classification report. Okay, I won't rerun this because the last task is still running at random forest classifier. But here we can see the overall precision recall F1 score right here. The precision is 0.76, recall is 0.74, F1 is 0.68. Basically, you want all these to be pretty close to zero. Close to 1. The higher, the better, right? If it's close to 1, you're all set. If this is 0.95, 0.95, 0.95 across the board, then we're done. This model is performing. We have the classification report here. But if it's underperforming, we're going to have to go with a different model, right? It's just not able to make those kind of predictions. So the last one just ran. I think we got 0.73. Okay. So again, getting kind of close, but we really want to try different models at this point and get at least close to 85. Ideally, more like 90 or 95 would be great, right? So you can make very accurate predictions once the model has been trained. So there's other things we can do. Let me say, I put in some notes. We did quite a bit already. I don't want this video to drag on and on, but a couple things you could try. I actually did try this, and I didn't have a lot of success because of the nature of the data. Sometimes these tasks just don't work. The experiment just doesn't work out. There's too many missing data points in one of these time series, the dates, but I would like to see how trends change over time. I tried it, it didn't work out, but that's something, if your data set has a complete set of dates, you can try that. You can develop heat maps and understand reviewer scores and even see how those change over time, or just at one single point in time. And could do latent Dietrich allocation. That's how different words are broken out into different patterns of words or different groupings of words. So the data was sourced from here. I always put in a data source when I put together these videos so you can see where the data comes from, download it, and then literally copy and paste this code that I'm going to share with you right now, and then run it and see how it works, right? You can play around with the code, make changes, modifications, understand the nuances, and understand the concept better. So that's pretty much it. Thanks for your time today. Have a great day.